So welcome back for the 7.3 video. This is part of solving equations, part of this quadratic formula, this piece underneath the radical right here, the b squared minus 4ac, can tell us some really good information about what's going on with the graph and where our zeros are, if we have any, and how many we would have. So that's a good benefit without having to actually solve the whole quadratic formula. So that piece, b squared minus 4ac, is called the discriminant right here, discriminant. And when you get the value of that discriminant, it tells you something. So if the discriminant, once you get that result, is negative, it tells us that there are two complex solutions containing I. If that discriminant equals 0, then there's one rational solution. And if there's a positive number that is also a perfect square, there are two rational solutions. If there's a positive number that is not a perfect square, there's two irrational solutions. So let's look at some examples of the discriminant. We're going to use, we're going to find the discriminant value, and we're going to use that to find the number and kinds of solutions that we have. So A is equal to 1, B is equal to a -1, and C is a -12. The entire quadratic has to be on the left-hand side, on one side of the equation to find A, B, and C. So we're looking for b squared minus 4ac. So that would be a -1 squared minus 4 times A times C. This will be 1 plus, because it's a negative times a negative, 48. So it's 49, which is greater than 0. So it's positive number that is a perfect square. So 49 is a perfect square, so it's two rational solutions. So we need to actually put 4 on the other side. So A is equal to 9, B is equal to 12, and C is equal to a +4. So b squared minus 4ac is 12 squared minus 4 times A times C. So we have 144. Subtracting 36 times 4 is 144. So it's equal to 0. So that tells us, because it's equal to 0, right here, it's equal to 0. So we're going to have one rational solution. B, we have A is equal to 1, B is a -2, and C is 3. So we have a -2 squared minus 4 times 1 times 3, which is 4 subtracting 12, or -8. Because this is negative, we have two complex solutions. D. So A is equal to 4, B is equal to 0, and C is a -81. So we're going to have 0 subtracting 4 times a -81. So it's going to be 0, but it's positive. So this is 0 plus 16 times whatever that is. 16 times 81. 1296. So 1296 is greater than 0. And 1296, I didn't even check. 1296, is that a perfect square root? Is this a perfect square? It is. So it's a perfect square. So that tells us we have two rational solutions. So it's the perfect square of 36. So two rational solutions. And the last one where we're finding the discriminant, we're going to move this 3x to the other side. So we have 4x squared minus 3x minus 5. So A is 4, B is a negative 3, and C is a negative 5. So we have a negative 3 minus 4 times a negative 5. So 9 plus, because and it's negative times a negative, so it's plus 16 times 5 is 90, 99, which is greater than 0. It's not a perfect square. So we have two irrational solutions. Pretty cool how that tells us that information. Okay, now the last half of this lesson, we're actually going to go in the opposite direction. So far in chapter 7 here, we've been figuring and finding different ways besides factoring to solve a quadratic equation for its zeros. Now we're going to go backwards. I'm going to tell you what the zeros are, and we're going to build our original quadratic equation. So if I know I have a 0 at x equals minus 5, I can add 5 to both sides. And I know that x plus 5 is one of my factors. And if I add 2 to both sides, I also know that x plus 2 is one of my factors. And then if I multiply these together, that is going to be my base possible solution. Now, I could have some kind of a different a on here, but this is my base quadratic that would have these two solutions. So let's look at B. So adding 4 to both sides and subtracting 2 from both sides, we would get these two factors of x plus 4 and x minus 2. And then when we multiply them together, we have x squared plus 2x minus 8 as our possible quadratic. Now C, that's cool. We have, these must be conjugates. So this would be an x minus 1 and x plus 1, and then an x minus 3. So this is a cubic equation. So those conjugates, we're going to multiply those first. So those are going to create an x squared minus 1. And then we're going to subtract that or multiply that by x minus 3. So we'll have x cubed minus 3x squared minus x plus 3 as our possible function. These are fun because these are a little bit trickier. So we could say we're going to subtract 1/3 from both sides, but I'm going to multiply by 3. So it's 3x equals 1. And then subtract 1, we actually have 3x minus 1 equals 0. So we don't want to have any fractions. That's the key, is we want to create factors that are no fractions in them. And then we have x minus 5 equals 0. So this function has a factor of 3x minus 1 and x minus 5. And when we multiply these, we have 3x squared minus 15x plus, so minus 15x minus x plus 5. So our possible quadratic is 3x squared minus 16x plus 5. And letter E, we have, we're going to do the same. We're going to multiply both sides by 5. So we have 5x equals a negative 4, and then adding 4 to both sides. 5x plus 4 will be one of our factors. And then we have x equals 2 is x minus 2 equals 0. So x minus 2 is one of our factors. And now we can FOIL these to get 5x squared minus 10x plus 4x minus 8. So our possible quadratic is 5x squared minus 6x minus 8. And that is all for lesson 7.3. Catch me back for 7.4 video.